Here we have a 4-port USB charger that charges fine, but makes a very annoying high-pitched screeching-like sound, which is quite annoying if you want to charge some devices overnight and want to sleep at the same time. It has some blue LEDs that give it a nice Star Trek-y appearance, and it looks like not all of them are working. So let's open it up and see what we can do. First, let's see if we need to discharge any capacitors. We don't want any electric shocks. And apparently we do. When we look at the board a little closer, we can see that the LEDs are in series with a 1 kilo ohm resistor. 102 means 10 with 2 extra zeros. So it's either the resistors or the LEDs that are failing. Since the board only needs 5 volts to operate, I scratched off some of the protective coating of the ground and 5 volt planes to connect my bench power supply set at 5 volts. Now it will be a lot safer to work on without the mains connected. When measuring the voltages on the LEDs, the working LEDs get about 2.7 volts, the dimly lit one 1.7 volts and the broken one 2.3 volts. So it might be the resistors. To prevent any screws or other removed parts to get lost, I usually stick them to a piece of paper with a rough sketch of the device they were taken from and number them sequentially. In this way, parts cannot get lost or put in the wrong place when reassembling. This method really has been very valuable with projects that involve a large number of parts. Let's leave the LEDs and resistors for a while and tackle the main problem, the noisy transformer. To expose the laminated core of the transformer, we first removed the yellow tape, which took a bit of time and a few different pliers and tweezers, but I won't bore you with the whole process. The tape was removed eventually. After exposing the core, I protected my dear blue mat with a layer of aluminium foil, or if you're from the US, aluminum foil, and a layer of kitchen tissue, and put a substantial part of a small tube of superglue, cyanoacrylate, on the transformer, which was happily soaking it all up. I removed the PCB from the kitchen tissue to prevent it getting stuck to the PCB and let it dry overnight. After the glue was fully cured, I plugged it in and the noise was gone. Also, one of the LEDs that didn't work previously started working again. That was a bit of a surprise. To check whether we found a revolutionary way of fixing broken resistors with superglue, I put some superglue on the resistors feeding the LEDs. After drying overnight and dreaming about millions of subscribers to watch that new method of fixing electric components, it turned out that it didn't work. One of the previous working LEDs even stopped working. But that million subscribers dream didn't fade, so please subscribe. It's free and it will help me a lot. Thank you so much if you do. So how about we replace the resistor of one of the LEDs that doesn't light up, which was a little bit difficult because some idiot put superglue all over the place. If you also have a blue mat, those lint rollers are great for cleaning it up. And there we have it, a beautiful shiny new resistor to provide our LED with the correct voltage. And the LED does light up, but seems to be emitting Morse code. This might very well be a message from aliens passing Earth in another dimension. So if you know Morse code, please leave their message in the comments. We don't want any flickering LEDs, so let's replace it with another one. ET knows how to use a telephone, so there's really no need to use our USB charger to phone home. One more try with a new resistor to get the other LED shining its light again. And apparently it does shine again, but not very convincing, so let's replace that one as well. And they all are shining brightly now. Only one seems to be a little bit dimmer than the others, but that is probably unnoticeable when it's all back together. Let's measure those tiny resistors and LEDs we removed. Well, how about that? The resistors measure 1 kilo ohm and the LEDs light up, so it's the combination of the two. Since it was a bit easier to change out the LEDs, I'd change the LEDs first if I were you having the same problem. Diodes are more prone to break than resistors in general anyway. Now let's put everything back together. And there we have it, a nice and quiet USB charger with all LEDs working and no alien interference. Thank you so much for watching, please subscribe and I hope you will join me in the next video. Bye then!